This video will go over the procedures in order to graph a polynomial of high degree. In this case, our job is to graph the given polynomial p of x. The first thing we're going to do is going to start off with finding and using the rational root theorem. And the rational root theorem states that you can find possible rational roots by getting the factors of the constant and divide them by the factors of the leading coefficient. So, in our case, we need to find the factors of 6, because 6 is our constant, as well as finding the factors of 2, because 2 is our leading coefficient. When we do that, we're going to see that the factors of 6 are 1, 2, 3, and 6. The factors of 2 are 1 and 2. So we're going to do that for every single one of them. I am going to get one factor of my constant, in this case 1, and I'm going to put it over each of the factors of the leading coefficient. So 1 over 1, 1 over 2. Then I'm going to go to the next one, which is 2, and 2 over 1, and 2 over 2, and so forth. 3 over 1, 3 over 2, 6 over 1, 6 over 2. And now I'm going to reduce them. So all of these become 1, because 1 over 1 is 1. I also have 1/2. 2, because 2 over 1 is 2. And notice 2 over 2 is also 1 again. So I'm going to put a line underneath the 1 to show that that happened more than one time. The next one is 3. Then I have 3 over 2. Then I have 6. And then I have 6 over 2, which is 3, which we already have. So I underlined it as well to show that that number occurred twice. So remember, because we didn't take in consideration the positive or negatives, all of these can be positive or negative. We didn't take that into consideration when we were finding the factors, but I will here at the end. So after we do that, the second thing we need to do is start guessing. We're going to use synthetic division and these numbers that we found here to determine which one will be a factor or not. So we're going to first set up our synthetic division using our polynomial. Our polynomial is 2, and I'm going to put a little x to the 5th to remind myself that I need a value for x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1, and the constant. So then 5, that's x to the 4th, the coefficient of that. And then negative 9, that's the coefficient of x cubed. Negative 11, that's the coefficient of x squared. 19, that's a coefficient of x. And then minus 6, this is our constant. And now we're going to guess. Because I underlined 1 and I underlined 3, those are going to be my first guesses. So the first thing we're going to do is guess 1. When I'm guessing 1, I'm going to put my work in green. So first thing I'm going to do is bring down the 2. Multiply 2 times 1 is 2. Add. Multiply, I get 7. Add. Multiply, I get negative 2. When I add, I get negative 13. Multiply, I get negative 13. And I add, I get positive 6. When I multiply 1 times 6 is 6. And negative 6 plus 6 is 0. Because of the remainder theorem says this. It says, well, if you plugged in f of 1, this is the one from our little box of our synthetic division, and the remainder was 0, then we would find this guy here. F of 1 is equal to 0, which is the point 1 comma 0. The factor theorem says if the remainder is 0, which our case it is, then that means x minus your number, in our case 1, is a factor of our polynomial. So what does that mean for us? That means that we can rewrite our polynomial p of x as x minus 1, because we found this to be a factor because of the factor theorem. And what's left is going to be what we call the depressed polynomial, which would be 2x to the 4th. Remember, it started off at x to the 5th, but because it's the depressed polynomial, it's 1 degree less. So it would be 2x to the 4th plus 7x cubed minus 2x squared minus 13x plus 6. So we've gotten one factor. Now we need to keep doing more guesses, except this time we're going to factor this polynomial. So here we go. Our job is to factor 2x to the 4th plus 7x cubed minus 2x squared minus 13x. Oops, I don't need to put my x there. And then 6. Because 6 is now my new constant. And again, notice we have the same values of the constant and the leading coefficient, so we can still keep pulling from our list that we had listed in part 1. So the ones that we have over here highlighted. We already tried the 1. We can try negative 1 if we want to. For fun, let's try 2. Notice 2 does not have an underline on it, which means it didn't happen more than once. I guess my next best guess would be a 3. But I want to show you what happens at 2. Maybe we'll get one, maybe we won't. We're going to show our work in green. We're going to see that we're going to bring down the 2. Multiply, I get 4. Add, I get 11. 22. And I add, I get 20. When I multiply, I get 40. When I add, I get 27. Either way, we can see that this is going to be what? 54. And when we add is a 60. So from our remainder theorem, what we have found is that if you plug in 2, the value is 60, or the point 2 comma 60. This is not a factor, because the factor theorem says for it to be a factor, the remainder has to be 0. So we know we don't have a factor. So x minus 2 is not a factor. So it didn't work. But that's okay. It just tells me that we just have some point. We don't even know what it is. So didn't do any good for us. We don't need that point because that is for the x to the 4th polynomial, not my x to the 5th polynomial that we started off with. So really didn't tell us anything. All right, so we're going to do this process again. This time let's try that 3 we said. So I'm going to use the same depressed polynomial and see if 3 works. So I am going to bring down my 2, multiply, add, multiply. Oh, I can see that this is getting a little out of hand. I don't think we're going to make it. So what I'm going to do is I'm going to go back and let's try negative 3. You'll see why I want to try negative 3, because at first we brought down the 2. When we multiplied, we had a 6. But notice, now I'm going to get negative 6. When I add, I get a positive 1. When I multiply, I get negative 3. When I add, I get a negative 5. And when I multiply, I'm going to get a positive 15. When I add, I get a positive 2. When I multiply, I get negative 6. And when I add, I get 0. So again, from the remainder theorem, we know that's equal to 0. But more importantly, the factor theorem says if the remainder is 0, you have found a factor. So we found the factor x minus a negative 3, or x plus 3. So what does that mean to us? That means our polynomial, p of x, was originally that x minus 1 that we started off with. And then our x to the 4th, the 2x to the 4th, I factored as x plus 3. That's from this guy right here. And what's left is this depressed polynomial. So it was x to the 4th, so now it's going to be 2x cubed plus 1x squared minus 5x plus 2. So now I just need to factor this cubic that we have here. Notice that we have new constant and leading coefficients. So our constant is 1 and 2, our leading coefficient is 1 and 2. So in other words, don't guess 6, even though 6 was a possible guess for our original polynomial, but for this depressed one, it's not. So we should either try 1 or 1/2 or 2 or back to 1. So that's what it says. So we either try a 1, and notice we had 2 sets of 1. So maybe we should try another 1 and see what happens. So I'm going to do that. I'm going to get my depressed polynomial. That's this one with the highlighted green. So it'll be 2, that's our x cubed, plus 1x squared minus 5x plus 2. That's our constant. So I said maybe we should try a 1 again. So I'm going to try a 1, put my work in green, get a 2, multiply, I get 2, I add, I get 3, multiply, I get 3, I add, I get negative 2, 1 times a negative 2 is a negative 2, when I add, I get 0. Aha! Again, the remainder is 0, which means this is a factor. What does that mean? So let's go ahead and get our polynomial, our p of x. And remember, we have our x minus 1 from the first try. We have our x plus 3 from the second try. And then our cubic is going to be x minus 1 because of that 1 right there. And then I would have 2x squared plus 3x minus 2. And that's a quadratic. So I know I can have p of x, and I'm going to rearrange some of these to be x minus 1 squared because I have 2 of them. I'm going to still have x plus 3. And then I'm going to factor this quadratic. So I'm going to have 2x and x. I know I have to have a 2 over here, because if I had a 2 over here, that means a GCF of 2 should have happened, but it didn't. And a 1 here, so that's going to be 4x like this. I need that to be positive. And minus 1x, that will give me my positive 3x. And negative 1 times a positive 2 will give me my negative 2. So in terms of factoring, I think this is working. So we have everything in factored form, and we can see that from our linear factored form, meaning that each thing inside of parentheses is linear, a line. So we have factored completely. We are done. We are ready to start graphing. So now the next thing I need to find out is our zeros. Because we have it in factored form, we know our zeros from the first parentheses will be 1. And it has a multiplicity of 2 because of the degree of the parentheses is 2, because we have 2 of them. That's good to know. We'll talk a little bit more about that. From the second parentheses, we have negative 3 with a multiplicity of 1. The third one, we have 1/2. Remember what we're doing. We're getting each parentheses and we're setting them equal to 0. So 2x minus 1, 2x is equal to 1, x is equal to 1/2. So that's where this 1/2 is coming from. Okay, and it has a multiplicity of 1. And then the last one, we can see that's negative 2, again with the multiplicity of 1. Now, why am I worried about these multiplicities? Because what we know is that if it has a multiplicity of 1, then it will actually go through that point. So if here's my 0, it will go either through like this, or it can go the opposite slope. But either way, it'll only cross at one time, and it'll go straight through. If it has a multiplicity of 2, then that's what we call a bounce or a touch, where it touches and it comes back up in that same direction, or it can also be going down, right? So just do that, something like that. But it just touches, but doesn't go through it. And if it had a multiplicity of 3, it's what I call a swivel. So it will actually go through this point, but it'll come approaching it and then kind of wiggle around it, swerve to get to it. So it should remind us of our cubic function. Alrighty, last thing, so that's what we know. The last thing we need to look at are a couple of points. One point in particular is the y-intercept. So I'm going to find that in a minute. Remember, that's when x is equal to 0 and we find our y value. We can plug it into our factored form, or I'm just going to go plug it into our polynomial that we had at the very beginning. In other words, I'm up here and I'm going to plug in 0 for x. And all of these are going to have 0 in it, and it's just going to equal to -6. So that's how I found the y-intercept, by plugging it in. So we got -6. The last thing we need to do is look at end behaviors. Because we have our polynomial was 2x to the 5th, and it kept on going. Because the degree is odd, I know it's going to go in opposite directions. Because the leading coefficient is positive, it will go like this, just like our cubic, that would go like that. So I just want to remind you that now we're ready to use these end behaviors, our points, our zeros, our slope, y-intercept in order to graph. So here we go. I'm going to get x and y axes. Now I'm going to give you dotted paper, so you can make your axes whichever size you want to make it. But more importantly, it's so that you can choose whatever scale you need appropriately. So notice I have a half right here. So what I'm going to do is I'm going to go by halves. So in our graph, I'm going to say this is a half, this is 1, 1.5, this is 2. Let's see what else we need. We need -half, -1, -2, -3, and it keeps on going. All right, so I think we found all of our numbers here. Okay, so now I'm going to go plug in or plot my zeros. There's a 0 at 1, at -3, at 1/2, and at -2. So those are these points that we just finished graphing. These are our zeros. Okay. Our y-intercept is 0, -6, so it's going to be somewhere down here. So I'm just going to go, I'm just going to say this is -3 and this is -6. So notice that my scales are different, and that's okay. I just want to make sure I get the gist of my graph. All right, so we've graphed everything. I needed a 0, -6. And now we're ready to do our end behaviors. Notice our end behaviors say if you go to the far left, it goes down. If you go to the far right, it goes up. Okay, at -3, the multiplicity is 1, so it needs to go through it. But it needs to turn around and come back to 2. At -2, the multiplicity is 1, so it needs to go through it. And notice my next 0 is over here, so I have to get over there, go through my y-intercept, go to here to half, has a multiplicity of 1, so I need to go through it. But notice at 1, I have a multiplicity of 2, which says I need to come back down and bounce and go back up. So notice I try to make this curvy, because your graph should not have any straight peaks or anything. It should be a smooth curve. And there's our graph. We're done. Make sure to include arrows at the end so you know that it continues going in that direction. We graphed all the zeros and their multiplicity, the y-intercept, as well as the end behavior. And that concludes this video.